Three, two, one. People of the internet. Why did I fuck up my video yesterday? You might be asking. Well, my editing software shit fucked. Okay, my editing software fucked. So, I had to install CapCut. I'm from India. CapCut is banned here, so I could not use those all features. Then I went to what a sane guy would do, DaVinci Resolve. It's like me opening DaVinci Resolve was same feeling. Me as a first year opening the book of object-oriented programming in C++. This shit doesn't exist. I could not understand shit, but I did enough to, kind of upload the 3 minutes of content that you guys had yesterday. Be grateful I'm doing it. I'm saying be grateful that I'm doing it. Have it while you can. Today, what you gonna do today? That's a good question you asked. Today we're gonna improve our binary sort algorithm, and I hope we have good time complexities. I think I have figured it out. I mean, this is the first time I love I'm understanding code, and this is maybe a miracle, guys. Maybe we never know, it's a miracle. So let's see. Let's go there. Let's just minimize my window and go on. Hmm. So you can see the screen. Fantastic. So this is it. This is it. Let's write the code for binary search. I already did the code for binary search, but we were lagging. Things were lagging. So just let me let me just update the code a bit. It was not the true iteration of binary search that I've done before. Now we'll start. So first we'll do high and low. One will be high, one will be low. That will be the starting index of the array, and one will be high. That will be the ending index of the array. So let's see. Int low is equal to 0. We'll start with 0 because it is 0 base indexing. Int high is equal to nums dot length minus 1. Why the minus 1, you ask? Because we are starting from 0. So the end index would be, yes, not the length, but 1 minus the length. Let's go. Good, good, good. So what we'll do now? We'll do a while loop now. While. And we'll put an universal condition. High is greater than or equal to low. Then we'll continue the loop. Now we'll divide the array into two halves. Why? Makes it easier. We dumb fucks. I'm so sorry, I didn't mean to abuse. Let's see. Uh, so let int mid is equal to what you gonna do is low plus high minus low divided by 2. That is how you know that is how you do the mid part. I don't know how it works. Hopefully I'm correct. So initially low will be 0. So it will give us for the initial iteration, it will give us low plus high by 2. That is how you find out the mid. You take the lowest term, you take the highest term, and you divide it by 2. But as the loop iterates, so the mid will change. The mid will go from, you know, how can I explain? Yeah, just the mid will change. Understand it that way. Let's see. Now comes the part, the tricky part. If norm set mid, what if the midterm matches our target? Just return mid. Cool. Well done. What if, what if our mid term is lower than the target? C. So this is a sorted C. Okay. This is a sorted array, and our mid is the middle part, and our target is greater than mid. So what will happen? Our target lies in the second half of the array. So what we will do? We'll start low from. We'll shift the low to after mid. So we basically discarded everything before mid, and now we'll search in after mid. Cool. What if you ask? What if it's the other way around? What if the target is less than the mid? Then what? So see, if the target was bigger, so we brought the front part to, you know, we changed the indexing of the array. We took the second half. Now, if the target is smaller than mid, we have to take the first half. So how will we do the first half? Ask me. Yes. Yep. We'll bring back the, see, low is already at zero. So what we have to do to end in the first half? Yes. We'll take the high and we'll put it in one before mid. So let's see. So high is equal to mid minus one. Cool. All conditions are done. Huh. What else do we have to do? Yeah. Or else we need to return one minus one. I think this should work. Heh, heh. Where did I miss? Heh. Ah, yeah, here. It's always the small things. It's always them small things. It's working. Let me submit my code. Let's see how will you know, how will my code run? Will it be optimal? But it is not optimal. What can I do? Let's see the memory graph. It is not optimal. Let me let me just search for optimal binary search tree. Just binary search. Let's see. Hmm. I don't have time to read all this. So what you're gonna do? We're going to the next question. Yeah, we're going to the next question. So we are done with our searching algorithms. Now we'll go for sorting algorithms. You might ask, what is sorting? Good question. Good question, you see. Searching is like when we find in the dictionary, but the dictionary is already sorted. What does that mean? Suppose in a dictionary there are letters from A to Z. So when you open the dictionary, it's always sorted. A is at the first, Z is at the last, or Z at the last. That is basically sorting. When an array is given to you and it has the elements are jumbles. Suppose the array is 1, 3, 5, 7, 8, 9. Oh, it says sorted. Shit, I said I'm sorted array. So suppose 7, 6, 3, 9, 8, 1. So we have to sort it. So how will we do? 1 will come at first, 3 will come, then 6 will come, then 7 will come, and at last 9 will come. Yes, I remember. I am not wrong. I think we'll go to sorting tomorrow. Today we have to do. They have given us selection sort. So basically, how selection sort works, and since I have looked at it also, you find the first you always use searching. You find the smallest element of an array, and then you swap it at the end, starting of the array, and you keep doing it until you find until the whole array is sorted, and at last it's like no sort. Will come back tomorrow. I hope it works. And it's looking good. It is asking Cognizant, PwC, Mindtree, Dell, Raja Software Labs, and LTI. Cool. Now I'll do the YAP video very soon. Let's go.